The year is 2012. You wake up, you brush your teeth, you brush your hair. Maybe you buy a cup of coffee on your way into the city. You go out with friends for a drink after work. You smoke that occasional social cigarette. You discard 330,000 nanograms of DNA. Until one day, an artist picks up that cigarette butt, extracts the DNA, analyzes it, and puts your face, puts your DNA on display. So in my project, Stranger Visions, I collected forensic evidence that strangers left in public spaces. I extracted their DNA and I analyzed it to generate full-color, life-size 3D portraits of what these people might look like. It was an algorithmic project through and through, from how I chose the samples that I collected to the DNA extraction protocol, the alignment of the sequences, the calls of traits from the data. But the primary algorithm, of course, is the translation from data to a face. I started working on this project with a fairly clear research question in mind. How much can I learn about someone from a hair? And how can I visualize this information? How can I make the vulnerability of this incredibly personal data palpable? And I knew what I didn't want it to look like. This kind of fetishized, very abstract DNA portrait that no one can actually interpret. Instead, I wanted to render DNA in a way that was immediately accessible, where anyone could walk in and see it and think, that could be me, that could be my DNA. And so I chose the form of the portrait. And when I started the project, I didn't know if this was actually possible. It was a question. What I discovered was that this practice of rendering faces from DNA was called DNA phenotyping. And there were a handful of scientists and labs trying to make this not only possible scientifically, but deployable as a tool to the police to create a new kind of police sketch. No one had really done it yet. No one had gone all the way to completion. But there was a bunch of preliminary research scattered around in bits and pieces. And what I did was collect it. I stitched together the established research for things like eye color with the more speculative research on things like weight and facial shape. I dug into all the different ways that scientists were attempting to read physical traits from DNA. And like an artist working in any medium, when you spend time and really immerse yourself in a practice with a material, you come to understand its structure, the way it bends, the way it breaks. And with algorithms, the underlying structure tells you a lot about their creator. As has already come up, we tend to look at technical systems as neutral black boxes. But if you open them up and look at the component parts, really they embody the assumptions and motivations of their creators. What I learned in doing this research was that DNA phenotyping relies heavily on statistics. It's based on a process of building a data set, coupling 3D facial scans to DNA samples taken from research volunteers. These scans are processed to create what's called face space, a probabilistic space representing all possible faces, drawn from and limited by that initial set of 3D scans. Finally, the data is mined for correlations between DNA and facial characteristics in ways that align with preconceived dichotomies of possible traits. So things like male versus female, heavy versus light, old versus young. and most troubling perhaps, European versus African. The act of creating computational averages and looking for correlated features in large data sets has an air of authenticity and scientific validity to it. But what this actually does is create a system of types. And you might call them stereotypes. And if this sounds eerily familiar to anyone in the audience, it's because someone else was very interested in this kind of averaging of faces and taking lots of images and compositing them together to create or find types. Types like the violent criminal, the thief, the diseased, the Jew. He also used this technique to find ideals, the norm against which deviance could be judged. Ideals like scientists. This was Sir Francis Galton, cousin to Charles Darwin, popularizer of the fingerprint as a mode of identification, and of course the inventor of eugenics. This kind of statistical averaging of faces, this attempt to categorize and read types from the body, to determine identity through measuring, imaging, or analyzing bodies and their traces has a very long history, and DNA is simply the latest in a long succession of what you might call identity inscribing technologies. And so when you examine these algorithms that pose as neutral, when you deconstruct their logic, you find a hidden history. You find a set of assumptions. In this case, the assumption that that identity is biological, that characteristics like gender and race can be read from the body and quantified as percentages. And when you start with these kinds of assumptions already in place, it isn't exactly surprising that you can discover them using statistics. I question the assumption of neutrality attributed to these algorithms. If we enter data into software and get racial percentages as output, it displaces the act of performing a racial stereotype. It isn't us. It's the black box. It's numbers, it's math, it's science. It doesn't appear biased. The bias is hidden. And so to conclude, I think one of the most interesting and important ways that artists can use algorithms today is critically and self-reflexively, using the visual to make the invisible apparent, to allow us to see and confront some of these biases and contradictions and limitations in different ways than other forms of media do, allow us to feel it, make it visceral, make us uncomfortable. And to wrap up, I think we need to bring the subjectivity of the algorithm to the fore and to implicate all of us in the hidden workings of the black box. Thank you.